Today we'll be discussing about linked list. So first we declare a structure named struct node, and I'm having two members in it. Int data implies I'm storing integer type of data into my linked list, and I am having one more pointer variable named next of data type struct node. And I'm using type def here, and I'm renaming struct node to node. And first let's go to the main program. In the main program, I have declared a pointer variable head of type node, and I have initialized its value to null. That is, initially I do not have any values stored in my linked list, so the head will not point to any location, so I'm making it null. I'm using a while loop in order to give me options to insert at the rear, delete at the rear, display, or insert at the beginning, delete at the beginning, and insert at any given position. Let's see the functions one by one. Uh, to insert at the end, what we do is we take two variables, uh, a current variable, a, a current pointer variable, and a pointer variable named new node of type node. I am assigning the value of stored at head to the current, that is the pointer variable current. Then we read the value to be stored in the linked list, that is the number to be inserted. I'm going to allocate memory for just one node, that is I'm going to use the malloc function, and the size of this is the syntax of the malloc function, and the allocated memory address gets stored in the new node. So new node of data, I will assign num to new node of data, and new node next, that is next of the linked list, is made null. I will first check if there are no elements in the linked list, that is if head is equal to null, then the new node itself becomes head, that is just one element is present in the linked list. Else I will have to navigate till the end, that is when current next is not equal to null, current equal to current next, that is I go to the last node. Then when I reach the last node, then I assign the current next to new node, and I return the head to the main function as it is. For inserting at beginning, we go through a similar process. We allocate memory, we store the number into that into the data of the new node, and we make the next as null. If head is null, again we have just one element, so we store new node into head and return it back as it is. Else new node next is made current. Current was our head here, so we are making new node next as current, and head is made new node, that is I'm inserting at the beginning. So the new node which I've made will be the head of the linked list, and the new node next will be the remaining linked list. So I am assigning the current to new node next and new node to head, and I return head to the main function. And while deleting, I will assign head to current, and the current next is made as head. Then I free the current, that is the first element is being deleted, so the second element, that is current next, is made the head, and I'll just free the current position, and I return the head. This is delete beginning. If I want to delete the end element, first I'll have to check if the current or the head is equal to null or not. I'm assigning head to current here, so if current is equal to null, then print it's empty. Otherwise, if current next is equal to null, that is there is only one element in the linked list, then head is made null, and I am printing which I'm deleting, the number that I'm deleting, and then I free the current. Else we have to navigate till the last element of the linked list. So I'm using one more pointer variable of type node previous. So I'm going to store the current value in previous, and I'm shifting the current value to the next one until the current next is not equal to null. That is till I get the last uh, element in the linked list. When I get the last element in the linked list, that is the number that I want to delete. So I'm printing it here, and we have the previous from here, so the previous next becomes null as I'm freeing the last one, that is the current is pointing to the last one, so I free it and I make the previous next to null. And when we want to insert at a given position, we can do it in many different ways, but here I have taken the count, that is the user has to give the position value. So I am asking for the position, that is the first position or the second position or whatsoever. For initially I'm assigning count to 1 here, and I am reading the number. I'm using malloc function as it is to create a new node, and I'm going to put the data into that new node, and I'm making new node next is null. So if count is equal to position, that is if the position given is 1, then new node next is made current, and head equal to new node. This is similar to that of inserting an element at the beginning. Else, while current is not equal to null, we need to keep a track of if of the previous element as well, as we are inserting it in between. So we are storing current in previous and current equal to current next, and we are going on incrementing count. If count is equal to position, then the previous next, that is the new element to be inserted is between previous and current. So previous next is made the new node, and new node next is made the current in order to insert it in between them, and at the end we return head. And lastly, to display an element, the elements of the linked list, what we do is if current is equal to null, that is if it's empty, then we are printing empty. Else, while the current is not equal to null, we go on traversing from the beginning of the linked list to the end of the linked list by current equal to current next and printing all the data, and we return head to the main function.